Tips and strategies for dealing with one-dimensional motion, either horizontal or vertical. Let's do a car problem first, the horizontal. Marty has 0.4 miles of road to work with. We converted that in the last problem. It's about 643 meters. He's starting from rest. That's an initial velocity of 0. We also, in the last problem, converted our acceleration to 3.57 meters per second squared. Don't skimp on those units. They're the difference between the right and the wrong answer. One way of answering this problem is to see what the final velocity Marty would have is after his 643 meters of road. Has he made it to 39.4 meters per second, in which case he's gone into time warp and he's fine? Or is he still poking around at 30 meters per second, in which case he's not fine? An alternate way is to say that he needs to get to 39.4 meters per second and see whether he has enough road. If he needs 200 meters to get to 39.4 meters per second, will he be okay? Well, he's got 643 meters of road. If he needs 800 meters to get to 39.4 meters per second, will he be okay? No, he doesn't have 800 meters of road. In any case, the only equation that does not have the letter t that will let us find what we want from what we need is this one. Substitute carefully. I'm going to see how fast he's going at the end of the road. VI is 0. Don't lose the plus sign. 2. Don't just copy the number. Put the unit down too. How do you know it's acceleration? Because it's in meters per second squared. How do you know it's displacement? Because it's in meters. This gives me a number. What is it? Well, you're copying. This number is VF squared. How do you get rid of a squared? You got to take a square root. You're not done with the problem yet. If you're curious about the units, it's meters times meters over seconds times seconds. And by taking the square root and checking the direction, which is forward, we should get VF. Did he make it to 39.4 meters per second? Long ago. He is somewhere in the 67 point somethings. The answer to this question is yes, he will be fine. How did you know? Because his final velocity was at 39.4 long before he reached the end of the road. If instead you asked how much road do you need and found that Marty only needed 217 meters of road, you will also get the final answer of yes, he will be fine. Let's try a problem that's vertical. Again, we start with our laundry list. What do we know? This is free fall. The acceleration is negative 9.81 meters per second squared downwards. How do we know it's acceleration? Because it's in meters. This number, which is the only one given in digits and decimals, is meters. It's not meters per second. This number is a displacement. Wait a minute. Check the direction. Down. Check the direction. 8 meters. If you drop a pencil, it goes down. That change in displacement is negative because the pencil ends up below where you started. Now, let's do that demo again. Here's the pencil. I'm going to drop it. Right now, what's its initial velocity? Now, when I'm holding it, before I drop it. If the pencil stayed in focus long enough for you to answer the question, you'll realize that drop is by definition an initial velocity of 0. Throw can be a positive number, pencil goes up, or toss downward, a negative number, if pencil goes down. In any case, how fast is the pencil moving? That's the F. How long did it take? That's T. So, with 2 questions, this is really 2 problems. I need an equation with T, VI, D, and A. I believe I will try this one. We know VI, it's 0. Plug the numbers in. Meters for displacement. Don't forget you're falling down. Acceleration is negative 9.81. Check your units. Meters per second squared. Multiply these numbers out. Will you need a square root before you're done? Yes, you certainly will. Don't be careless with your algebra. This is times negative 4.095t squared. The opposite of times is not plus or minus. It is divided by. Be careful with your algebra. Be careful with your units. You do not have to divide by t squared because t squared is the answer. Pay attention to what you're doing. Got an answer. It's 1.63. Am I done yet? No. That was t squared. That means you still have to take the square root before you get a final answer of about 1.3 seconds. Now, for final velocity, you'll need a different equation. You can choose just about any equation you want now that we have time. If you went straight to this one, noting that the initial velocity was 0, and you have 2 times negative 9.81 times negative 8 meters. Notice meters per second squared for acceleration. Meters for displacement. 2 negatives make a positive. Again, don't be careless. This is not VF. This is VF squared. And you will still need to take the square root of what you found there to get a final velocity of approximately 13-ish meters per second. Big picture, how do you know what number goes where? You look at the units. If it's dropped, that's initial velocity of 0. If it's in the air, that's an acceleration of negative 9.81 meters per second squared. If it's moving down, that's negative velocity. If it's ending lower than it started, that is negative displacement. Put those negatives in. For instance, in this one, 120 meters is the change in displacement, but unless that brick is falling up, the change in displacement is negative 120 meters. To go with your freebie of acceleration, 9.81 meters per second squared. Oh wait, negative, because I checked the direction. For a change, we now have t, and the word drops means our trusty old initial velocity of 0. Do you know which of these numbers have to do with this question? Pause the video and tag which of those 4 pieces of information have to do with this question. Ready? Have you checked? In those 1.5 seconds, it's in the air. Time is measured in seconds. It started from rest. It fell, but it didn't fall all 120 meters yet. If you want to know how far it's fallen, our good old standby equation number 3, starting from rest, makes our lives easier, will tell you how many of those 120 meters the brick has fallen. That is a different question than this one. How long will it take for the brick to hit the ground? Well, assuming you didn't get 120 for this. To hit the ground, that's this. It's going to be in the air. It will be starting from rest, but it's not going to take 1.5 seconds to fall. It's going to take longer. You can use the same equation if you want to, knowing delta D, knowing that this term still cancels out, but this time t is the question. Solve for t. If you know how far down you're going, and you know that these negatives are going to cancel out, and you're careful with your units, you can see what t is going to be this go-round, and see whether it's more than 1.5. I bet it will be. And if it is, how much more is it? How much time after the warning is given do the people below have to get out of the way? Good luck!